All right, welcome. Thank you all for coming. I'm really excited about this presentation. I'm always excited about speaking about rapid energy modeling. It's my favorite topic because I firmly believe this will change the way you do your business. So I want you to keep yourself open, take a lot of notes, be inquisitive, ask a lot of questions because at the end of this, I would like you to start thinking about how you would apply rapid energy modeling workflows at your work practices starting Monday. Deal? I would like you to think about how you would apply rapid energy modeling workflows to your practices on Monday. All right. Let's go through some legalese. So some of the statements, and you might have seen this in other Autodesk presentations, we base our statements based on our current estimates. We cannot predict the future, so can't you. So please don't make purchasing decisions based on these statements, and we don't have the obligations to change any of these. So legal made me do this. And just so that you know that you're in the right session, these are the learning objectives. Hopefully we are on the same page. We'll go through why we need rapid energy modeling, what kind of rapid energy modeling workflows there are, some of the key important takeaways you should remember on Monday. And then we'll go through a case study. We just recently completed a Department of Defense project on 23 buildings, and we'll talk about that in a minute. And the agenda mirrors that, and this is USGBC wanted us to do this, have an agenda slide that exactly mirrored the learning objectives, which is kind of redundant, but I'll use this time to ask some questions. How many architects in the crowd? A third. Engineers? Wonderful. Contractors? Real estate folks? Anyone who does existing building audits and assessments? How many of you know rapid energy modeling? Oh, wonderful. Oh, excellent. If I miss anything, I will call upon you guys to fill the gaps. So the first agenda item is understand why we need retrofit assessments. There's a lot of research showing a huge amount of energy savings stemming from energy retrofits. This one is from Rockefeller Institute and Deutsche Bank, but there are similar studies from McKinsey, from AIA, around $1 trillion that can be saved in the next 10 years through deep energy retrofits. And this saving can be realized through minimal investment that could give a whopping 358% return on investment. And it's just not vaporware. There's other research that shows that around $1 trillion is actually being spent on commercial building energy retrofits. And where is this demand coming from? A lot of this demand is coming from regulations. Standards like Title 24 and the new ASHRAE standard mandate energy modeling for commercial buildings. You guys probably already know about the 13514, but this one's fresh off the press. US Army Corps Energy and Construction Bulletin, which mandates energy modeling on all new construction and existing building retrofits for any buildings above 5,000 square feet, which is any building, absolutely every building. Where federal buildings have gaps and state building codes and regulations have gaps, a lot of cities are stepping up. Number of reasons. Cities have a much larger footprint than many other rural areas. Most of the population lives in cities. A lot of greenhouse gas emission comes from cities. In cities like New York, 70, 80, 90% of greenhouse gas emission comes from cities. Cities also have a better control over the energy ordinances and local energy retrofit programs, so they are able to tweak and monitor the programs better. And business leaders are warming up to that fact as well. Number of studies by CBRE, by Navigant, this one's from Schneider Electric, which polled. Johnson Control comes up with a similar study every year, which showed how a big portion of business leaders are investing in energy efficiency because of cost reasons and because of return on investment, and also to acquire a good talent force which is conscious about energy assessment and sustainability. Renovation forms a big portion of the AEC revenue, your revenue stream, and we know the energy retrofits are often piggybacked on renovations. So you know all this, how do you now start thinking about getting the energy retrofit done? It's all around data. You need data around the existing performance of the building. You need data about the potential performance of the building. You need weather data. You need climate server data. You need data on the occupancy and schedule. Data, data, data. And there are good ways of collecting data. There are bad ways of collecting data. A lot of times what you'll notice is, and I see some people peering out. I think some of the sides are getting compressed. There are a lot of times when you see facility managers running around like chickens with their heads cut off because they're running after individual complaints. You have a hot spot, you have a cold spot, you have a leak, your gadget or smart meter tells you something, this new thingamajiggy that you installed is telling you something else, the BMS system, if it works, is telling you something else, and you're running around fixing these low-hanging fruits or medium-hanging fruits without understanding what the overall consumption of the building should be and what a strategic energy management program should be. So I would like to present a framework to you, the framework of model, measure, and manage. You start with model first. Why? Because a building information model takes into account a building's structure, its construction material, its orientation, its occupancy, the window-to-wall ratio, daylighting. I mean, think about, I can understand step number 2, measurement. It gives you some kind of tangible results, and it's like stepping on a weighing scale every day, realizing that you have gained 2 pounds because you have been dining out quite a bit in Louisiana and making use of the southern food. And it's a good indicator, but would you create a long-term health program without understanding a person's gender, his height, bone density, race, activity level, dietary conditions? Those kind of things are what feed into a model. So your first step is to understand what a building's potential is. You can't just compare 2 buildings, look at the Energy Star score, and say this building is better than the other building, because you don't know where the building is located, what the weather pattern is. So number 1, model. Then you go to measurement, and the advantage of that is the measurements that you get help you tweak the model and optimize the model so that you have a measurement and verification loop in there. And both of them together would feed into an integrated building management system. So the next question is, if you know how to collect data and if you know how to create a model, and please, there are a number of my colleagues out there, they can talk to you about building information modeling and what the benefits are. How do you scale that up? This used to be a domain of a handful of experts, and that the pool of engineers is dwindling down. If you look at the STEM enrollment, that's dwindling down. Even if that were not the case, the fact that this information exists with only few engineering firms is always a problem. And when we looked at this problem and we interviewed a number of customers and the market a few years ago, we realized that the status quo was just not enough. Let me ask you a question. How long will it take to do an energy assessment on the entire US building commercial stock? 13 years. If you employ 1,000 auditors, not few, 1,000 auditors, they're working around the clock, 365 days a year, and they just spend 1 day on energy assessments, it would still take them 13 years to complete it. More time than the time between the last CBEX and today. So we realized very quickly that the current ways of assessing energy is just not scalable, it's not enough. So what do people do? They do quick benchmarking, or they do quick back of the napkin, they install gadgets, and they are not able to rectify the structural problems of an existing building. How should a building behave given the weather conditions, given the location, given the geography, given what you know about the building occupancy and building type? And we came up with rapid energy modeling. The thesis behind rapid energy modeling was, can you use a little bit more data, a little bit more information than you were before, and get a whole lot more without spending a lot of time and resources and costs, and without having experts who had 20 years of experience peering down stairwells and going around the building with a flashlight and having a master's degree in engineering, and we need those people, by the way, but for deeper energy retrofit recommendations, not for assessing quickly how a building should be performing and how does it compare against other buildings. And rapid energy modeling gives you very good information, and we'll talk about that in a second, much more information than ASHRAE Level 1. In fact, it runs a DOTU simulation underneath, which is not even asked for in ASHRAE Level 2. Only ASHRAE Level 3 asks for energy modeling. And it drastically reduces your time and cost. And some of the emerging technologies have drastically, they enabled rapid energy modeling a few years ago, but they drastically accelerate the rapid energy modeling process. Some of them, like cloud computing, that help you access data from 24/7 anytime. You have infinite computing, and that computing power is getting cheaper and cheaper. Mobile technology that helps you access data from anywhere and any place. Building information modeling, which we have made a name on, where it's a 3D model, but the biggest power of BIM is the I in BIM, the information. A number of different trades, from architects to fabricators to MEP engineers, can continue to add information to the same building information model, so that the same BIM can pay you dividends throughout the life cycle of the building, post early stage, post detailed design, post construction into occupancy, because the same BIM can then be used to talk with sensors and get more information and feed it into the same building information model. And reality capture. This is a technology which essentially converts your analog world, what you see around you, existing conditions, into digital form. And once it's in digital form, we can easily create a model and feed it to an energy analysis engine. So a lot of work has been done on reality capture in our company, which everything from photogrammetry to laser scanning to drones with GoPro cameras on them, you name it, satellite pictures, aerial imagery, and so on. And some of that technology that we have used on large infrastructure, city level scale, we have also used for buildings. And that technology is now in your hands. You can use it very quickly, even on an iPad, and I'll show a demo quickly on that. So what is rapid energy modeling? Rapid energy modeling, first of all, is creating a 3D model. The first step in your energy assessment process. And you can either do a very quick conceptual model using masses and just quick metrics on lighting power density and window to wall ratio and so on. Or you can use a detailed model that a contractor or an architect might have used. And from those models, we can quickly create analysis. You don't even need to go to another tool. But just for your information, the tool that we run under the hood is called Green Building Studio. And that creates a whole lot of energy analysis reports and metrics that you will see shortly. We also have a partnership with First Fuel. So if you do have access to utility data, interval data, we can use that data and create analytics report. And the difference between the two reports is an energy report that you get from building modeling and analysis. It gives you design ECMs. What does that mean? ECMs, energy conservation measures that have to do with changing facade, changing windows, single pane to triple pane, adding daylighting controls, adding insulation, those kind of things. The energy conservation measures that you get from utility analytics or sensors give you operation in ECMs. They'll tell you if a diffuser is not working, if the economizer is not working, if the schedule is out of whack, if the set points are not set correctly. And both of them together will give you much richer insight. How many of you know about the IPMVP option C, option D? A few people. Option C is essentially around getting metered, sub-meter data and doing meter level analysis, which is what analytics does. And option D is running a calibrated simulation. And I'm digressing a bit, but this is an important point about, this also ties to the point of asset rating versus operational rating. How many of you know about asset rating, a building's asset rating, and how it differs from operational rating? The asset rating tells you what the building's inherent energy consumption is based on its structure, its orientation, where it's located in the world, what kind of window to wall ratio it has, and that is what is obtained from modeling. Whereas the operational rating is that extra layer on top of asset rating, and that depends on your building use. If you're an investment bank running 24/7, your energy consumption will be higher than somebody who's using the building much more diligently. And that is true even if you think about making your own purchasing decisions. If any of you have purchased a house recently or seen any of your friends purchase a house, You don't care how the previous tenants use the house. They could have used it in any fashion they wanted. You know how you're going to use the house. Your family requirements might be different. And so what you care about is the asset rating when you're buying or selling real estate, when you're leasing real estate, when you're assessing buildings across zip code or benchmarking them against other buildings of the same type. What makes all this really unique, and what is the core of rapid energy modeling, and what makes it rapid is reality capture. Because the first problem you face when you start assessing the energy of a building is, how do you get the existing building conditions? If you know absolutely nothing about the building, or if the owner is unwilling to share data, or if you have problems with data, sometimes even if you have utility analytics, you have holes in the data and it's not accurate, whatever reason, you can't get in much information. You can start with as little as satellite pictures and quickly get to an energy report. If you have photographs, you can start with photographs, walk around the building, take pictures on your iPad, feed into our modeling tool, and it'll spit out an energy report. And of course, if you have drawings, we have tools that do that, laser scan, laser measure, same thing. What really happens is, because of all this, it makes the whole process quick, cost-effective, and insightful. And there's a double entendre with Rapid. Rapid it's quick, but it also reduces the expertise and reduces the entry to barrier to energy modeling. So now we want high school students to be able to do rapid energy modeling with this. Go around the block and start taking pictures and getting energy reports. As I mentioned, satellite pictures to energy report. I have trained real estate professionals with absolutely zero knowledge of engineering or architecture, or who know nothing about modeling. I've trained them in 20 minutes, and they were able to get energy report in 20 minutes. This just shows you how that's done. We have a tool called Vasari, and we have now new tools called Format, which do this. You take a satellite picture, quickly import that image, draw an outline around the image, and then extrude that, create a number of floors, and add a few building parameters, and immediately get an energy report. It's called Vasari, V-A-S-A-R-I. It is in beta until May, but we have new tools called Format that are taking over, so we should have something soon. But this is something where financiers and real estate agent, a big, I won't name names, but a big real estate firm, I was able to train their sustainability manager on the phone, not even in person, show this to them. It comes equipped with pictures and videos and instruction documents and everything. And I firmly believe you can get to this very quickly. Yeah, good question. Can I hold that question for a bit? I'll get to it very quickly, and you'll be surprised. And that's really the reason why rapid energy modeling works and it delivers, is you can get that kind of accuracy. Let me fast forward this in the interest of time.
So what are we watching here?
They are inputting envelope characteristics, and we are giving very few knobs to the user. So we don't want him to be confused by all the detailed Revit kind of stuff. I don't know how many of you know Revit. Most of you. I mean, we don't want. So if you have a Revit model, that's great. I mean, you already know Revit. But here we give you very few options. For example, insulation. Is it highly insulated, medium insulated, low insulated? Construction material. Cold climate, medium climate, warm climate, hot climate. What else? Glazing percentage. You don't have to drop windows. You can just say 40% glazing approximately. The cool thing about this is, once you run a simulation in Green Building Studio, we actually run 40 simulations in the background. So we run the sensitivity behind the scenes. So even if you put in 40% glazing, we will change that from its lowest value to highest value and come up with a sensitivity list, which I'll talk about quickly. So that even though you might have some uncertainty around inputs, or you might not have data, you still know the ballpark in which we should land on. Yes, so when you enter the, good question. So when you enter the address, the first step, if you remember, we entered the address, it brought up a satellite picture. We already know the location. What's more important is we have the accurate weather file. So we don't use the airport weather file. We actually have a meteorologist on staff. We have close to 2 million weather stations mapped across the world. So the nearest weather station should not be more than a couple of miles away from your building location. So that takes into account issues like terrain, differences in terrain, and microclimates, which place like San Francisco is famous for, so that you get as accurate an image as you can to the best of your capacity. Photogrammetry, same three-step process: capture, model, analyze. It's not always the case that you need 3 different softwares for that, by the way. We have already integrated modeling and analysis. Sometimes the capture portion might be in a different tool. In this case, if you have photographs, you use one of our tools called Reality Capture that essentially converts all the pictures, 2-dimensional pictures, into a 3D model. So here's a Marriott hotel. We got a bunch of pictures. It does automatic calibration, creates a 3D model out of it, and we have a shape extraction tool that helps you outline what portions of that point cloud that is created is a wall, and so it helps you draw it. It gives you the measurements. It just makes modeling much more easier. And once you do that, click a button and you get the energy report. And I'll be going through some of the energy metrics as well shortly. And once you have a 3D model, of course, you can do walkthroughs. And those of you familiar with Revit, I think you probably are more of an expert in Revit than I am. All the power of Revit is at your disposal at that point. If you have Survey Instruments, this is a partner company in Boston that actually uses Survey Instruments, the $600 distometer that people use for surveys. And let me reduce the volume. How do I do that? Oh, there's no volume button. So essentially, he's using a distometer, and his software sends the measurements via Bluetooth to the laptop. And while he's walking around a building, it's automatically creating a Revit model on the fly, except the floors and roof. So all that you need to do once you go back to your office is add the floors, add the roofs, and you have a 3D model. I hope I can mute this. So yeah, the company is called Point Known, and they essentially do this as a service for surveyors and civil engineers and people who need to do site assessments and so on. Again, without walking into the building, without disturbing the building owner. In this case, I guess you need a permission to go around the building and get on the campus, but very little intrusion with the tenants or occupants' processes. So that's Survey Instruments. Of course, we have software that converts laser point clouds if you have the budget to do laser scanning, and laser scanners are getting very cheap. I've been at Autodesk for 5 years. When I joined, it was Faro laser scanner was $350,000. Now at the last Spark conference, they have unveiled $40,000 laser scanners, 1/10 the cost, and it's getting cheaper by the day. You can also get laser scanning services for $100 an hour, so it's not being in the means. And then there are other ways: infrared, CAD files, raster files. You can convert all of them into a model and get an energy report. This is fresh off the press. It was announced yesterday, and this is all of that you learned today. Rapid energy modeling is now on an iPad. We have tried to democratize this even further, where you have an iPad, you know which building you want to assess, you take a satellite picture, outline the boundaries of this building, and then you go on site and use your iPad camera to take pictures of the building. You just need 3, 4, 5 pictures at the most, and this is what it's going to show. So this person is walking around the building taking pictures. And once you have those pictures, because the pictures that we get from iPad are geolocated, we already know where the camera locations are. That's the biggest problem in photogrammetry. From where have you clicked the pictures? And here it's made easier because iPad sends you all the GPS and GIS information. And once you have that, we already know the geometry because we have outlined the building, and we know the camera locations. We can easily create a three-dimensional model. It'll be slightly off, so you might have to tweak the vertices a little bit and move them up and down and change the floor lines and so on, and then add windows and so on, and then click a button. It'll run a Green Building Studio simulation if you have Wi-Fi or 3G. Otherwise, you'll have to come get back to your office or trailer and get some connectivity and have all the power of the Green Building Studio energy analysis at your disposal. This is another R&D project right now. This is a rapid energy modeling at a city scale. So the challenge that the cities posed to us was, what if I wanted to do energy analysis on an entire block or an eco district? So here we use some of the shape files that we get from the city, some of the publicly available data on number of floors and the tenant usage and so on, and create a whole city model inside our tool called InfraWorks. We have mapped a number of cities, Vancouver, San Francisco, for example, and we know what the building type is. So somebody can just drag, like here, they can drag a box, and we already know which building is which, and start creating energy reports on it. Then we know we can also leverage that for other things. We know the rooftop area, so we know how much solar potential there is, how much green stormwater potential there is, what's the potential for capturing runoff water. So those kind of analysis then can be spawned from a simple exercise such as this. So what do you get from this? So one thing is, I tell our clients is, rapid energy modeling makes things quick, but it's not quick and dirty. A lot of sophistication actually runs under the hood. Things like DO2 simulation, how many guys of you know eQuest or DO2 Energy Plus, used to take ages. And those things are still needed because, as you could imagine, we are using very rough parameters. So if you are now trying to do investment grade audit, you of course have to now go in and start using some of the engineering tools. And the cool thing about that is you can easily export this into some of the engineering analysis tools. And we already run DO2, and we have donated code for Energy Plus as well. We gave them 70 times speed up. So we are doing a lot of effort there. But all this used to be done by a few MEP firms, and it was just getting quite complicated. And now we are running all this simulation under the hood, and gives you this report on building performance factors, energy use intensity, aggregated fuel and electricity usage, the annual carbon emission, life cycle costs, heating and cooling loads, peak demand, windrows diagrams, temperature bins. This is the most powerful, the biggest takeaway of this report is potential energy savings. Think about this for a second. Without stepping into a building, without asking for a whole bunch of data, without looking at utility meters, just based on building information modeling and other data around weather and some of the ASHRAE defaults we put in, we already know which energy conservation measures offer an improvement opportunity and which energy conservation measures are more sensitive to some parameters. So maybe if your inputs are wrong, these are the ones that are most sensitive, the ones with the widest bar, which you should go with caution because they actually could lead to more losses than benefits if done improperly, and which energy conservation measures are not worth going after. So think about a window manufacturer or dealer. Today he's flipping through the yellow pages and starting from alphabet A and just calling upon people, asking them to change a single pane to triple pane without knowing anything. Now he can actually scope out his neighborhood and think about which buildings are most suited for changing of windows, because maybe some houses have, or some buildings have a great daylight penetration and they don't need anything special. This answers your question, hopefully. we ran double-blind studies on our buildings, and we were pleasantly surprised that rapid energy modeling can come pretty close to the actual energy consumption. And there's a reason for that. We have actually run research where adding more and more details and interior information around how the office space is laid out and the programming of the floors changes very little on the overall energy consumption of the building. That is because of the asset rating. Now, I can imagine the doubt that's creeping in your mind is, what if somebody's leaving the door open, the occupancy schedule is out of whack, if there's an investment bank running 24/7, 365 days a year, for sure the numbers would change. And that's what we need to get from a survey of the building owner. So a little bit more information can add a whole lot of accuracy. But even with minimal information, you can get pretty darn close. And even in cases where you do see a deviation, like the one in center, either your assumptions are wrong and you can go back. Like here we found there was a data center in the basement. The facility manager didn't tell us. It was very easy to go back and change the model and come back with a new number. But I still like to show this because it can either point you to incorrect assumptions that you should go and fix anyways, or it points to operational inefficiencies. So one of our big customers, a construction company, saw a similar chart and realized $55,000 worth of saving when they saw this deviation. They sent somebody on site and they found that the heating and cooling were fighting against each other because the dead band between the set points was not set correctly, without doing an expensive audit. An audit would have cost them $10,000. Does that answer your question? And that's what was. Actually, we ran this, so I don't know exactly which tool this is. We actually ran on all of them. They're similar results. They don't change much. Photogrammetry, Vasari, satellite. We ran a number of different studies. So as promised, here's a case study. I want to bring all of what you learned so far into the case study. Department of Defense wanted a way to streamline the energy assessment process. You may or may not know they account for almost 80% of the federal energy use. Across a number of buildings, they have some 500 installations with 300,000 buildings. And the biggest problem is they don't have much data. Many of the meters don't work. Most of the meters don't work, or they have insufficient or inaccurate data available. And in many cases, they have to send people on site, conduct large amounts of studies, and which results into very costly assessments. So we did rapid energy modeling on 23 of their buildings across 8 installations and 5 climate zones, accounting for more than 1 million square feet of conditioned space. And we got some good results. First of all, the reduction in time and cost. I mean, this is the biggest takeaway for all of you, because it reduces your time and cost for energy assessments, and it helps you take on more business than you're able to do right now. 95% reduction in an equivalent on-site audit. I would say 1.5 level on-site audit. What's that? On the 23 installations, we send people on a few sites as a control experiment, and the rest of the buildings, we didn't have to send anybody on site. We did an interview in the beginning to verify some of the parameters, like window to wall ratio. What we are seeing on Google is the same thing as it's there. Is it accurate? So there is a survey form that people fill out. It's probably a dozen questions. And then after the fact, we do another interview asking them to compare with meter data. And it's all run double blind because they're trying to evaluate our technology. What's more, it took less than a day to train this personnel, and that was an eye-opener for them. Local facility managers who have minimal sort of experience or expertise in modeling and architecture, engineering, and so on, were able to get trained on this in less than a day. And any given assessment took less than 3 hours. In fact, a typical rapid energy modeling would, on average, we ran some sensitivity and some statistical analysis. It was 17 minutes. But if you add to it another run and maybe some scenario analysis and creating the report and gathering data and checking with the facility managers and so on, it's still less than 3 hours. And REM delivered the accuracy, more so in electricity. So we were plus or minus 20% as far as electricity is concerned. Gas was less, I would say, less accurate than we had imagined, but we later found out that there was a lot of infiltration. There were not well insulated buildings, DOD buildings, and there was a lot of just infiltration that ate up into the HVAC, the heating load, which was taken by gas. And we have seen this a few times. Luckily, here the gas consumption accounted for very little of the utility bill, 10%, 15%. And so we didn't worry too much about it. We have actually found that in buildings where the gas consumption is much more of the total energy bill, the gas modeling performs much better. Also, smaller buildings, there are a lot of issues, not only on infiltration, they are more climate sensitive. There are things like domestic hot water heating, so that's very difficult to model as well. So those are the things to take into account. What's more, you could deliver customized potential energy savings. So all these buildings were different from each other. These are not boilerplate audit reports. If you look at any ASHRAE level 2 audits, they're literally boilerplate reports. You change a few things and submit another report to the client. But here, you get a customized report, and in fact, we ran an audit on our own results and took a sample of 5 buildings. And out of the 5 buildings, 3 of the buildings we gave energy conservation measure recommendations that could lead to 30% or more savings. And that's deep energy retrofit. These are not low-hanging fruits. These are real considerations that a big energy hog like Department of Defense should consider.